Hello and welcome everybody to another episode of No Orientation Programming. I am Joe and today we will make some coding, a coding session, as always. But I don't know what we should code. I don't know if I want to code another example of Advent of Code, although there would be some work we have left. Last time we did day 11, but unfortunately part 2 was quite puzzling. So at the end I finally managed to get the right answer, but I must admit I needed a little bit of cheating. But nevertheless I finished the code, so it's working. So today would be day 12. We are behind 4 days. Whoa. Let's see. You try contacting the elves using your handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map of the surrounding area, your puzzle input. The height map shows the local area of the from above broken into grid. The elevation of each square of the grid is given by a single lowercase letter, where A is the lowest elevation, B is the next lowest, and so on up to the highest elevation set. Also included on the height map are marks for your current position S and the location that would get the best signal E. Your current position S has elevation A and the location that would get the best signal E has elevation Z. You would like to reach E, but to save energy you should do it in as few steps as possible. During each step you can move exactly one square up, down or left or right. To avoid needing to get out your climbing gear, the elevation of the destination square can be to avoid needing to get out of your climbing gear, the elevation of the destination square can be at most one higher than the elevation of your current square. That is, if your current elevation is M, you could step to elevation N, but not to elevation O. This also means that the elevation of the destination square can be much lower. That the elevation of the destination square can be much lower than the elevation of your current square. Here you start in the top left corner. Your goal is near the middle. You could start by moving down or right, but eventually you will need to head toward the E at the bottom. From there you can spiral around. To the goal. In the above the diagram, the symbols indicate whether the path exists each square moving up, down, left or right. The location that should get the best signal is still E, and point marks unvisited squares. This path creates the goal in 31 steps, the fewest possible. Okay. Seems to be an interesting example. So let's try it. Himbeere. So I always have two input files, the example and the official puzzle input. Hey, that looks cool. So that looks kind of cool. So file size. So let's check if this is working. Okay. Let's get input 1. Perfect. So I would say we store number of x0. We store the size of the map. If not number x, then calculate x and y. Number x is strlen offline, and num epsilon is size file divided by number x plus 1, I think. 8 and 5. No. Why? Why 5? Oh no, 5. 5 is fine. Okay. So that's fine. Okay, let's see if this is working for input 2 as well. This is 41. This file has 41 lines. And 144. Yep. Okay. So we have the size of the board. That's fine. Okay. If we have the size of the board, then string. We make a string map. Map is not a good name, I think. Map, hate map. and then we could reserve num epsilon entries, and let's try this in place. Don't know what this is doing exactly, but I think it's knowledge for in place string. Mm-hmm. Ah, okay. Uh-huh. Let's see. Okay, let's see if this did something. For vector string iterator iter is seems to be fine. So, okay. Okay. So, now we have the map. Then we want to get the number of steps for the fewest possible. Okay. I make another one. Res map. And we initialize the res map with a string that has number of x times this sign. Let's check this. Okay, this was wrong. No, segmentation for number x. Ah, Perfect. So now we have a function that should read the H map and print the result in a res map. So let's see. Should this function be recursive? I think I want to try a non-recursive way. I say count max is 1000 steps to avoid a endless loop, while count max minus minus, and then oh, no, I think we should I think we will need a recursive function. Okay. Yeah, it would be too easy. So what do we need? I try to go from every point I have an uint pos x is 0 and a uinteger pos epsilon is 0. And I have a uint depth is 0. Plus plus depth if depth is bigger than Okay. So. If we can if position x has a value other than 0, so we are in here, then we can check the left. Then we can check the left position. So if pos x and your integer height 1 and height 2, height now and height test. Height now is age difference. Height now is age map on pos epsilon not epsilon y, pos y, and the string pos x. So, and then I have a height difference, and that is smaller than 2. Let's see. I have a current height. If position has a value, and if this left position minus the current position is smaller than 2, this can be a negative value. So I change the stuff to integer, whatever, because it can be minus 0, negative. If it's smaller than 2, that means at the maximum of 1, then I can check, I can return I can make it easy if I don't draw the result. I will make it easy for me. So let's see. Steps is then trace find pos x minus 1 and pos y and then depth. If pos y, then pos x and pos y. If pos x smaller than number of x minus 1 and this stuff, nope, this stuff, plus is smaller than number of y minus 1 plus plus, okay, so then we got oh no. Ooh. That's not working. This would I have to at least lock the last position. Und wäre Banana. How are you doing? I'm always struggling with recursive functions. I have to code a recursive pathfinding stuff. I've done it before, but this was a couple of years ago. I have to lock the last position at least. Oh, cool. Wait a moment. While planning, I thought the planning is over. It's just executing. At this point. You're still planning? Not the mount, okay. Ah, yes, the mount. Yes, that's, ooh. Ho, ho, ho. Yes, absolutely. That's, ho, ho, ho. But that's a cool project. Should I add an old position? Array arrives on Monday. Cool. This would lock an old position. And if I have found if h map at position x no y pos x is equal to s and not num steps or num depth is smaller than smaller than num steps, then num steps is equal to depth. So if we have found S, no, E, the and now if we have, then we can return in If this is our last position, then otherwise try to find that stuff. And the result is the number of steps. So let's see. I'm forgetting the closing. Return no value. Okay, 0, whatever. Yes, whatever. Which one? Number X. Result is 0. Come on. Oh, yeah, of course. Plus X and plus epsilon. Minus X and minus epsilon. Y. Hmm. Let's see what is it doing. Inflog. Pause X and pause Y and H map of pause Y and pause X. Okay, we are reaching. What the hell? Four? Okay. So if pause X, no, and this is not working, this is not working, but these two should do something. Okay. Mhm. Okay. Okay. This is because we have an S here. Hopefully. I think this is the reason. Will this end someday? Maybe. But nevertheless, it's very inefficient. So, hmm. That's the reason why I have another map. I can check if I have visited. Okay. Okay, so. Which one should I choose? I think this is defined. Should I create such a map for every step? I don't know. Hmm. Up, down, left, right. The symbols indicate up on the location that should get the best signal is still E and max unvisited squares. There are multiple ways. Hey, Spitzmann. Hi. I'm still coding stupid stuff today. It's a cool example, but it's quite hard. I have to find a path on a mountain. This is the mountain map. And I have to get the shortest path to the highest point. Here, this is E and the start is somewhere else. Oh. Left center? I just... Oh, you're poor. Nice. I would have been able to search for S, but you saw it. Nice. Phew. And yeah, that's quite an interesting example because you need a recursive function, I think. But I think I also need for every step the complete state of the complete map. So I need for every recursive step but this can be quite big. If the map is a reference, yes, this would work. Yes, this would work. Of course, of course. Ah, yeah, yes, yes. Oh, that's a good one. That's a good one. So this is Yes, absolutely. Ah, that was a good idea. Thank you. I don't take a reference because I want to make a pointer because I want to make it. Yeah, let's make a reference. Okay, okay. Ah, rmap. Ah, trace map. Yeah, it doesn't matter. I thought I could. I will use. Always it just needs one. It just needs one. Hi, loving Scotty. I finally finished day 11, but it was it. I had to cheat a little bit. It was really quite hard. I will save three maps. The trace map. I have the trace map, and the res map is. I think this is it. So I have a trace map that tells me. Oh. Oh, yeah, Rust. I'm happy if I am able to solve the puzzles. Install it in client, can choose it, but says cargo isn't in. The fuck is cargo? Cargo is the package manager, I think, for Rust. I know very little about Rust, but I think yeah, the language itself has it. Why doesn't it yeah, That's a good question. Yeah, I would expect something like this. apt install Rust. This would be cool. Yes, that's a point. Banana. Banana always has a point. Indeed, that is a point. So I can replace tmap. I can replace this line if the current position x, if the tmap so I have to replace the res map stuff with the trace map. This is our trace map, and the res map is only here. And if this is smaller, then we replace the res map with our current tmap. Then we have found a new, better way. And this is the result. That's fine. Cool. Okay. This is if we have found a new way. And now we say the trace map, our trace map of position of our current position. If this is not equal than a new position, then we have to return immediately. Ah, that's cool. That's cool. This is our start. If this and is start or this equation, okay. So now, every time, that's cool, because now we are stepping through all the possibilities, step by step, and that's cool. If we have found E in the source map, we always have to check the source map. But we also have to change our T map in the ifs, our trace map, otherwise we don't have a trace. So that means here we decide to the trace map position epsilon y position y and position x. We choose to go to the left here. We give this function our T map. Our trace map. If we are finished, then I think should we restore the trace map? Here we decided to go up. Ah, okay. That does make sense. If you install a package manager for cargo, a package manager for us, then this actually, I think maybe if I install the language itself, then maybe I don't need the packages. But if I install a package manager for something I need to code, maybe for me it makes a little sense. Hopefully, more or less. So, which signs do I take? Okay. Plus. Yeah, I know. At first I didn't know this how is it called? I know it. The kappa. The kappa, yes. So here I go down because I increase the epsilon. The Y. Why do I say epsilon all the time? Should I restore the trace map? If I decide to go down one step, I execute this function with a new position. Oh, come on. With a new position. And pos X. Okay. Then I think, yeah, I should restore the map, I think. Then this is free again. This should be free again, I think. Okay. I am, yes, AOC, but day 12. I was thinking about if we should, yeah, yes. Did you code it already? Or let's try to execute this thing. Result, we have a result. Didn't do this one yet. We have a result, but it's the wrong result. That's funny. It should, they say the shortest path is 31 steps and we managed to get 25. So let's see. Theoretically, we should have a result in the result map. Yes, it looks something. It looks like, yeah, but this, so let's see. Is this step allowed? We can go from here to here, that's fine. We can go from here to here, that's fine. That's also fine, that's fine. Yes, it looks similar, but not completely right. So we can go JKLMN and OP. Cool. So you're learning Rust. Yeah, make day 12 with Rust. Loving Scotty. And that would be cool. Coder 2K is quite good in Rust already. He already solved a lot of examples. Which way is this thing taking? PQRSTUVE. Yes, I wasn't that much motivated with AOC the last days because it's quite similar every time, I think, for me. But the purpose would be to learn new stuff. So the best thing you can do is learn a new language with these examples. They are interesting, and the parsing, it's always parsing and finding best data structure and then do some algorithmic thing and then get a checksum. So it would be interesting to learn a new language. Yes, that's a lot of parsing. So I think I heard, I saw that some people call it advent of parsing. It's fine, but yeah, as you can see, I'm coding in C++, but I'm struggling with the recursive function. I do it because these examples often have graph theory examples and recursive function examples. So I'm training my brain for recursive thinking. As you can see, I can't code enough recursive functions to get fluent. It's very, very bad. This looks strange. This doesn't look like... because let's try to go up and down and left and right, like here. Up, down, up. Maybe this changes the result. Yes, this looks more like... no, okay. I can't... okay, Yes, that's wrong. I can't go from... I can't go directly from V to E. I have to go from Z. Oh. Yeah. Now I have to attach this stdlib for it. Oh, once I have made tried to get a Java hello world, and I wasn't able to create this. I couldn't create it because I needed some manifest file, whatever. I'm a C coder, C++ coder. I know I have my Meson file, I have my compiler, I have VI, and that's it. That's all I need. Yes, but on the other hand, for a beginner, it's hard to know that there can be compiler arguments. Vim is based. I love Vim. It's the best IDE. Hello, Evosh. So I want to finish this now. Come on. So I have a depth. I give this thing the last character, the current character, and then only if the last character is equal to set and if the character of the height of my parent is set and I found E, then I'm allowed to go to end this stuff and then I have the correct answer. So now I can get my puzzle input and then it will crash, I guess. Oh, reached max. Oh, come on. Oh. Yes, of course, I know. Bad stuff. Pfui. I have to increase this thing and how much? 40 times 144. 40 times 144. Netjen sehr sas netjen net as ser hit sas hot one. Oh, that's bad. My Hungarian is very bad. So, but the max, if I go round and round, then the max trace length should be, we could trace len max. Let's see. It's working and it's working. I don't know, this can take quite a while. There are many possibilities. For me, the interesting thing from AOC is that we could, with the processes, we could make this thing multi-threaded and maybe I could make a cool example out of it. So what is it doing? This is quite a big input. It's working. It's doing something. Should we... How... There are so many... I think there are so many possible traces. On the other hand, the traces are limited. No, but as you can see, in this area you can go to every possible direction. can be at the most one higher than the elevation of the current square. That is, if your current elevation is m, you could step to elevation n, but not to elevation O. This also means that the elevation of the destination square can be much lower than the elevation. So you can fall down, but you have to go little steps up. This is taking too long, I think. Yes, so this is... I'm not sure either, because on the other hand, I want to... just Rust JetBrains ID. I don't know if I want to continue with the gaming server. Netstart NTL. 4000. 4000. No, not Telnet. I would like to continue with the gaming server and the SSH server. I have coded an SSH server, and the server is quite... but I'm not sure. Connection refused. Why is it refused? The SSH port is 4001. I have to make a port. And the SSH server is already decrypting the stuff. So this is the authentication layer. And I'm thinking if I should continue with the authentication, SSH authentication. Yes, I think this is a good idea. I'm not motivated for the advent of code stuff at the moment. I mean, this is a cool example. There is something very inefficient with this algorithm. Is quite inefficient. I have coded, but whatever. I stop for today. Let's make an SSH session. I think this is more fun today. So, but it's quite a different story now. So, what are we doing at this point? So, if an SSH client connects to our server, Then the keys are exchanged and the decryption keys are derived. The server sends a signature to the client and the client verifies the signature of the server. So the server authentication is done on the transport layer, the encryption and decryption layer. Yes. I wanted to add so okay, let's see this. Let's open the RFC documentation. RFC authentication. Yes, that's fine. If a client connects and the keys are exchanged and the server authentication is done, then the client requests a service, and this service is the authentication service. The authentication service is we reply with a service accept message. That's fine. Then the client knows, okay, we accept the authentication service. And in the next step, the client tries to authenticate with I think we let's see what's happening if we make localhost p 4001 without if we don't add a username. This is the default username, the username of the system. If we use foo, for example, then we can change the username. So this is, if you specify a username for the SSH connection, then this is overruled. The default behavior is the name of the system user. Okay. We have received an authentication request. And at this point, yes, at this point we have to decide if the user is in the system. So we have to create another process that is okay, let's see. So I need I need a process that is telling me that a certain user is in the system and is allowed to do something. Or should I try to establish the SSH connection first? Okay, yes. I think that's the reason why I continued. Yes. So this message is this message. Did you learn SSH in your networks exam? What's all that takes it in out of the messages? No. This is the hex dump of the messages. If the client sends a message, then I print the content of the packet as hexadecimal numbers and the string representation of it. So this line in data bytes is this string. And we can see here, this is the length of the packet in network order. So this is the first byte, the least significant byte, then this is the most significant byte, so we have to switch this thing. This is the number of padding bytes in the packet. This is the packet type. The packet type is defined in that's the protocol architecture. This is defined here. If we have a service request, then this is the code for SSH message service SSH message service request. So, and this, the constant for this this constant is so similar how Ethernet frames are absolutely similar, yeah. And yes, and this number can be seen here. So if I get the message ID service request, then there must be a 5 at this point, and we see this 5 here. So this is a service request. And after the service request, we have encoded a string. This is the string. After the byte, we have a string. But a string here in this document is defined as a data sequence of a length, and then after that we have the actual string. So if we have the 5, then we don't get this string immediately. The string starts here. This is the string, and this is the length of the string. So in this document, at the beginning of the document, it's defined that a string is not just the string itself. It's not a null terminated string. It's different. You can either use a null terminated string, or you can store the string as a length and then the string itself without the null terminating. Yes, and because it doesn't, yes, that's absolutely right. Because you don't have the 0, you don't know how long it is, so you have to get the length in a different way. And that's the way. So you see a C here, and this C means 12, and let's see if the length is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So today this is more interesting to me than AOC. I'm sick of parsing stuff and recursive functions. So decrypting stuff is easier, I think, than recursive functions. So if I get a package like this, at this point, what do they have for the string represent? Just yes, the ASCII values. If you have 73 here, hexadecimal 73 means S, and that's an S. So 2S and then a H. So 68 must be H. These are the ASCII values. So it's quite easy actually. And at this point in the code, I'm just waiting for this authentication request. I have a timeout set. If I don't receive this service request, then I end the process with an error. If I got a message, I try to read every time. If I don't get any data, then I return pending. If the result is smaller than 0, then there was some connection error. If I got data, if this number of bytes is positive, then I got some data. I check if this data isn't too big for me, and I check some other stuff. And here at this point, I set the SSH server, the SSH header pointer to the beginning of the packet pointer. And then I check if this header has a message code. If this message code is not a service request, then something is strange, because at this point I expect a service request. If, on the other hand, the code is a service request, and as you can see, this must be a 5, of course, the constant. Then I have received a service request, and at this point I try to check if here I have the point of the string, and the point of the string is the packet buffer plus the size of the header plus its length. So I increase the pointer. I start with the pointer here, and then I start here. then I increase the pointer by the packet length, the header. This is this thing. This is the start, then this is the length, 6. And then I increase the pointer even more by size of uinteger 32. So by 4 bytes. And then I'm with the pointer at this point. And because I have 0 terminated the buffer, yes, try doing that with Java, lol, yeah. I love pointers. I don't have a problem with pointers. If you keep your program simple enough, then yes, sometimes it's a little pain in the ass, but I got used to use pointers, so for me they are cool. I like them. And at this point I just can check if this is the string, and if there was a service request to a different service, then I go out, user out request, but something else. But if we have found this string, then we have received the authentication service request, and then we send something back, and that is defined in also, you know if it's mutable or not, just because of if it's a point or a const reference, at least when people use good code style. Yes, absolutely. This is the reason, I mean, not everybody, this is not everybody's style, but for me, if this P is very important. The fact that it is a pointer is, for me, it's very important. Therefore, I use this Hungarian notation. I only use pointers if it's mutable and const refs if it's not. Oh, that's interesting. That's an interesting strategy. I don't use a lot of, I always use C++11 because I don't like all the fancy stuff of the higher standards. But one thing I use quite often, this is the const. It prevents if I'm writing to something I should not, then I get an error. If I want to write to something, so this is the first thing I do with a pointer, and then if the compiler complains that I'm not allowed to write to that location, then I have to rethink what I'm doing. So this is quite working for me. So, and in this document, but your strategy is also very interesting, dividing these two. If yes, in every of these documents you always have it always has these RFCs have a very similar structure. Yeah, absolutely. I get what you're saying. All the documents have a very similar structure. At first, you get the overview of the packet structure, like here, for example. The binary packet protocol is defined in page 7. Binary packet protocol. Each packet is in the following format from the transport layer. For example, you have a packet length, the padding length. We see here the packet length and the padding length. Then the payload. Then some random padding and the mark. That's the transport layer, and I have removed this stuff already because the padding is we don't see the padding here because at this stage the SSH protocol has 3 main parts. The first part is the transport layer. The second part is the authentication layer, and the third part is the channel, the data channel layer. And the authentication layer as well as the data channel layer are dependent on the transportation layer, of course, because here is the encryption and decryption done, and the padding is because of the encryption. If you decrypt something, then you have to do it in blocks. Like here, this is one block, I think. And the padding is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have for these bytes, so we can decrypt or encrypt and decrypt these bytes, we have to take a big block, and this big block has to be filled up with padding bytes, and that's the reason why here is an A standing. So every message I get, every message I send, it has to be a multiple of the encryption block. That's the reason. And because I have decrypted into what I was supposed to do. Yes. I don't like the OZ model that much, so why not just throw everything together and make it easier? Yes, so yes, the model itself I don't like, but yeah, you always have some structure that is like a, how is it called? Zwiebel. Oh, come on. I don't know the word Zwiebel. Come on. I'm so weak. Zwiebel. Onion. At the very moment I opened the tab, I knew it. So. In this protocol, all the transport stuff is defined. So we have a general description of a packet, and then in the other documents we can read what is the payload data. And the payload is if this is the user out request, this is a authentication requests. All authentication requests must use the following message format. Only the first few fields are defined. The remaining fields depend on the authentication method. We have different methods. We can authenticate with a password. We can authenticate with a key, an RSA key or something like that. So we have a service name and a method name, and that's what we see here, I think. This is the packet length, this is the padding length. Here we have 9 because 9 bytes are left to fill up the last block. Then we have 32. What does this 32 mean? That should be. What was what? This is the packet, and the packet begins with the packet length and then the padding length. And the padding length is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this packet has 3 blocks, and the last block needs to be filled up with 9 bytes. And this is the authentication request, this packet. And in this byte, we see what kind of packet is this. So, know what kind of key the token was I have seen when I was working in a backend for once. Know what kind of key the token was I have seen then when I was working in a backend for once. Is token a specific term for some form of key? Oh, token is a word that is very often used for different things. A token is sometimes it's some kind of if you're parsing something, for example, this can be a token. If you split a string into something, into multiple parts, it can be either a part of something or it can be it can be the part of a group. A token, authentication token. Yes, that's a different thing. An authentication token is something is very often used. You will see it quite often today. This is if you have a site, a system where you want to authenticate, then you very often have a private key. And with this private key, you can authenticate yourself to get access to a certain system. But you don't want to use the private key all the time, every time you make a connection or a request for something. So you are splitting a connection into 2 parts. The first part is authenticating with your private key stuff that is hashed or something. And then you authenticate and the server gives you an authentication token. And this is a thing you get like an permission, a permission to access some resources on the system. SSL, SSL is quite different. TLS and SSL. SSH, this is SSH, and that's a completely different protocol. And SSL and TLS is a different protocol. This is working like the client and the server in TLS, the client and the server exchange. It's called hello messages. There is a hello client and a hello server. So they introduce each other. It's quite similar. In some way, it's a little bit similar. Yeah, the hello messages. Yeah, the hello messages are just the beginning of a TLS connection, and the client hello contains some information. I only know one information at the moment. That is the session ID, for example. The client hello contains, I don't know, what does it contain? I think the algorithms, the possible algorithms for the encryption, and the encryption suite, a list of allowed algorithms, and the server hello contains at least the server certificate. In SSH, you don't have certificates included in the protocol, but in TLS you have. In TLS, when the server sends a server hello, then it adds its certificate, and the client can check if this certificate is known and trusted. The server can, for example, in the server hello, the server can request a client certificate from the client. So if the client gets a server hello, it can see if the server also wants to know if the identity of the client. That's not very often used, but it's an optional field. But the server certificate is required in TLS. And then the next step is similar to SSH, that the keys are generated and exchanged, and the authentication is different in TLS than in SSH. The authentication in TLS is done with the certificates. If you get the certificate from the server, then you have a database on your computer with all the just a directory with a lot of files, for example, where you can look, I have this certificate or not. And these certificates have the possibility that they can be signed. That means, for example, I tell you that I am Joe, and you have to decide if you trust Joe. So you can check in your list if the name Joe is on the list, then you trust me. If my name is not on the list, you don't trust me. But if I say that your grandma trusts me, then you can check in your list if you trust your grandma. Then you can also trust me. So this is the chain of trust. It's called the chain of trust. So if in your chain, for example, if you don't trust your grandma, but your grandma tells you that your grandma trusts her, then you can check in your list, do I trust my grandpa? And if yes, then if you trust your grandpa, then you trust your grandmother, and then you trust Joe. So that's the chain of trust. And you can add certificates to your database. Just install the certificate, then you trust this entity. And in SSH, it's completely different. In SSH, the server authentication is done in the transport layer during the exchange of the keys. The server takes the secure information that is calculated and then creates a hash of this data, from this data, and this hash of the secret data is signed by a host key. Yes, that's exactly. The whole trusting thing is also used in the internet between of clusters or network, isn't it? Yes. Can't remember the protocol name though. This should be TLS. For example, if I go to, then I have this sign here. No, this sign. Connection is secure. And you are securely connected to this site, verified by Google Trust Services LCC. And if I go to more information, then I have the website identity. This is because if you type HTTPS, this HTTPS is over SSL or TLS. Now it's the old version was SSL, Secure Socket Layer, and the new name for the new versions is Transport Layer Security. And this the web protocol, the secure version of it, is based on this protocol. And this is, and the output of this underlying layer, you can see here. If you press more information of this symbol, then you see the identity is this, and this is verified. So that means somebody tells you the name, I'm Joe, and here I can view the certificate, and that's the content of the certificate, and there are some informations, the public key. So this is the public key, and we have the fingerprint and stuff. We have, there must be a subject name. The subject name is for what is this certificate, and it's for everything from Google. Can't you spoof this though if you're just able to identify as, let's say, YouTube? I mean network address spaces and so on. No, that's not possible. That's not possible to spoof. That's the important thing. you can't say you're YouTube or Google. It's a very clever mechanism because if you can check if I say that I'm signed by your grandmother, that means that I have information in my certificate that is created by your grandmother, and this can only be created if you have the private key of the grandmother. If you take the public key of your grandmother that everyone can have, then you can, with this public key, check if this data is correct. If I say your grandmother trusts me, you can check if this is true, because you check this data inside my certificate, and then you can say, yes, I have used the public key of my from my grandmother, and only if the real grandmother, which has the private key, has created the data, then this makes sense. So at first you check if this was all very informative. Thank you very much. I will never be a network admin in this life though, probably. Yeah, it's the internet is very complex already, so it's very fancy stuff. I always wanted to. I thought that it's become pretty messed up. Yeah. At first it was just cat videos, and it was funny. Then after that we had secured cat videos. But it's very interesting that you have, I think, what secured cat videos. What fascinates me is that if you exchange, this is so interesting for me. Yeah, absolutely. So since all the certification and handshaking and encryption, it has even gotten its own wiki page. The wiki pages are very interesting to this topic, because what fascinates me is that two parties can exchange some number, some random number that can be visible for the public. And they are able to create on both sides a secret. And still we are not able to say, send my smartphone pics directly to another smartphone like my dad's, like the internet was supposed to do. Why do I have to send it to Google and shit, or what? Yes. Or WhatsApp servers to send him. Need an app for everything. Yes, you don't believe it, but sometimes I am not able to transfer the data from my smartphone to the computer. I always use the messengers like WhatsApp and Signal as a gateway. It's so strange. It's so strange. So here we have the authentication, the user authentication request with a username and a service name. The service name is, in this example, we want to authenticate for an SSH connection. And yes, please don't start. We have a service name. We want a authentication request for a specific service name. So the client wants to have an SSH connection for us. And the method used to authenticate the method name, then we have a method name, and then we have optional method specific fields. And at first, the client tries to authenticate with no method. That's so the first attempt of the client is just to get the access without anything further information. And in this document, the non-authentication request, the non-authentication is reserved and must not be listed as supported. However, it may be sent by the client, as we can see here. The server must always reject this request, unless the client is to be granted access without any authentication. Yes, that's interesting, yeah. Yes, it doesn't matter if you don't want the search the watch history from YouTube sent to third parties. It doesn't matter. They already have your search history for all the dirty stuff. And on YouTube you can't watch all the dirty stuff you're watching. So we have to reject this thing, and if we reject this message, then we should do this. So at this point we should not send an OK, but we should send I will call it in a little bit differently. So let's see. Out service, authentication service, response, send, for example, and let's bool OK is equal to false, for example. And here we check. Let's see. P string, and that's P check. And P check. P check is equal to this thing. And we have size T len check if we need it, maybe or not. Yes, len len check is equal to strlen of check if then okay, we have received this thing, and if we have received oh, come on, so that's the next one. This is okay, ooh, nope. I changed the wrong function. Oh, come on. So this is always okay, but the next this thing, authentication okay. Packet to big P header. We increase P header with the size of the header and the size of the string, because here we get not the size of the header. These are 6 bytes, yes, and then we have the size of should we make a function that fetches a string, so we don't have to make the whole pointer stuff? Good night, loving Scotty. It was nice to see you. I hope to see you next time. Was ist die Dimension von Kern von A, sage ich. Na, sehr gut. Bye. Bis zum nächsten Mal. So. Ja, Grüße nach online. Hi. Die box. The box is finished, yes. The box is... the hardware is finished. The hardware is finished, but the software isn't finished, and it's still not finished. The box is not finished. I only have to do the box itself. Looks quite good. And yes, the software still has to be done. But I made a Pause. Eine Pause habe ich gemacht. I'm already empty with my energy today. It's 10 o'clock, 10 and a half approximately. So we are coding some SSH stuff at the moment. So data encryption stuff. And not encryption. Encryption is done already. I tried to code some advent of code example today, but I was not motivated today. So I switched to our gaming server because the gaming server should be finished. Hardware ready is good. The software always needs the most effort. Not for the box case. I think, because the box was so annoying to make. I really have to. For today, no, I lost the track. And the end of code. I the I lost the track on the weekend. I was drinking and partying with my friends, so I lost the track, and then I tried to. I think the weekend was here at this point, and then everything went nuts. So this day was so hard for me. The second part of this day is this was crazy part, because this was the monkey stuff, and I tried to make it alone, but I had to cheat, because there was a very vague uh way a very vague requirement what you should do. So yes, it becomes harder. All the other people try to code in different languages. I just try to solve the stuff. And today it was finding a path, and it's working a little bit, but it's very inefficient. So it's working for this example, but it's not working for this big example. It's taking a lot of time. I could skip maybe. This could be the solution. If I skip a recursion step, I don't need a recursion step. As long as I can go into one direction, I think. Yeah. Okay. Yes, I will finish. I will finish the advent of code, but only on January, I think. I have cool. He's so, and he wants to get in the list. Hoo. Yes, that's very hard. So I've made the first year quite a lot, but yes, it's the examples are very interesting, but I'm at the moment I'm sick of it because all of the parsing and algorithmic stuff, and it's just parsing data, making a data structure, then just mangle the data around, and then create a checksum. And this checksum is it's cool, but it's very similar all the time. But I liked a lot of the examples are very interesting at some point. This example is very nice, and I liked this example was very cool. Yes. I like the examples where we have some the rope simulation, some physics stuff, or If the example is about graph theory, that's very cool for me. The rope example was very cool. Yeah, like this. This was the rope example. This was very cool because we had a rope and we had to simulate the rope. And this is something I can imagine to use someday. So this is quite cool. This is useful, maybe. Like this. So you have a head and a tail and you drag the head around. This was a very cool example. Because here you can learn actual a useful thing. There are very cool examples. Yes, phew. Today I didn't even manage to get one star today. That's very very sad. But whatever. So we switched to the SSH authentication. I tried to. I enjoy seeing how JHK solving the problems. He is a very good programmer. Okay, I don't know JHK. Is he a Twitch streamer? JH Krüger. I don't know him. Who is he? Uh-huh. Cool. Amiga. Uh-huh. Uh-huh. Retro Streamer. Uh-huh. Ah, cool. I will check his channel out. Thank you for the info. Ah, cool. Nice. Mm-hmm. So, so we are coding the SSH server, and the encryption layer is done already. It's working perfect as expected. So now we get the clear information of the authentication layer. And he also has a YouTube channel, and I mean there is another YouTube channel named Gravitar or Gravitar64. I mean that is also JHK, because listening to the Gravitar videos sound exactly like him. Cool. So I want to reject this message. So I will extend this authentication request response respond like this, and then we can give okay or no, not okay. And yes, this was the question, if we should make a function that is passing a string. It's as you can see, it's we are very far, so we are only a very few steps away from sending data over the channel. If some user is registering, so if we have the server running, you can connect to the server via telnet. Yes, I need to get the right port. This is working already, that's fine. In this mode, if you use the telnet channel, then you are a guest. You don't have to authenticate, and you get a random name. Yes, you get a random name, and if you use SSH, then you have to authenticate. And the SSH protocol is defined in the RFCs 2250 to 54, and these two are encryption RFCs. So the authentication layer is done in 4252, and the first thing the client tries is to authenticate with no method, and this must be rejected by the server unless the client is to be granted access without any authentication. But this will not be the case on this server. So let's see. I think I want okay. Message. I think I want to write a function because if we have a string mentioned in the RFC, for example, if we have a string in our packet, like here, then this string isn't stored as a zero terminated, a null terminated string. That's not a null terminated string, but it's a string stored as length and data, a length and string content. So I want to make a function that can just store the can store the content, the data, into a string variable and increase my data pointer. I want these two things to be done. So I can get this thing in an easy way. How should this? I would add this to the funny these days. As a video from Open and spinning CT scanners. It's incredible what's there going on. Yes. The scanners are very funny here. I left the server open, and there were a lot of telnet and SSH requests. Very funny. So like logs. These were the SSH clients that connected to the server, like a Go client, I think this is a Java thing, and this is some low-level coded stuff that is using libSSH with this version and this version. This is the second version. This is, I think, a scanner. This is putty. This is actually, yeah, putty. This is a putty client Very interesting. And then I got some weird stuff. Here, these are at least this is also quite shady, because the protocol says that for the client version it must have this prefix. If this prefix and a new line is present, then it's okay, and the rest is an optional name for the client. And if a client connects without the name, that's quite shady. But very interesting. So I tried to be careful during the whole data passing stuff. I tried to, if there is something shady in any way, the connection gets disconnected immediately. And yes, so this function must be quite stable, and this function should do two things. Like yes, I know. I use a patch from time to time, and I always have a look at the logs. And it's also, you can look. There are many clients, these send requests and are looking for every open security breaches for sending requests to known admin paths, etc. It's also funny. Yeah? With SSH and other services, it's the same thing in the logs. Yes, I once had a virtual machine running with the credentials Joe and password Joe, and there was an SSH connection, and I forwarded I opened the port to the open world. So it was quite a security breach, and yes, they logged into my system and they installed a Bitcoin miner, and that was very interesting because it was on a different machine, and then the network was slow at this time. So this was the only reason why I found this bot. So if you make a bad mistake, at this point you can't just security is a topic. Definitely, you can't just ignore it. There is no maybe nobody is watching or something like that. So I have the pointer to a data. It's often hard to take care of such things, but you should always watch what's going on to keep informed. Yes. The problem with the security stuff is you have many layers in your system, and the bad thing, there are two bad things on security. For me, I think that's my opinion. Two things are very, very hard to tackle. The first thing is it's not working like this strategy isn't working, that you have a hull, an outer layer that is protecting your inner system, and this layer, if this layer is very hard, then nobody can go into your system and break it, because if you enter the system, then you can always send into the system some strange stuff. So you have to make a security check on every layer of the system, no matter how deep you are. If I break the authentication layer for example, and then the system thinks that I am trustworthy and the data I send is trustworthy, then I can send bad data. Maybe I didn't break the authentication layer. Maybe I'm actually an authenticated user, but as authenticated user, I have the will to break the system. Then the system still has to defend itself. So it's going through all the layers, I think, in my opinion. And the second thing is, if you made one mistake, only one, then all the stuff is breaking down, because it's only as strong as the weakest part. So these two things are these 2 points are quite hard to tackle. That makes the security stuff so hard, I think. And as you say, what's going, you have to keep informed. You have to be informed all the time what's going on. If something is changing or new attacks are found, you always have to be up to date. That's another bad or a hard thing in security. I want to return the pointer of the end of my parsing stuff. How should I call this function? I call it buff string get, for example, and then I have a const char pointer. No, a char pointer. Yes, a char pointer to the buffer, and I have a pointer to buff end, and a string reference. I think this buff string get, buff string fetch. Yes, let's see. Lib SSH, byte add. So this function should get an string for me from a buffer. That means I have a uint len is equal to pbuff and minus pbuffer, and if len is smaller than the size of a uint32, then return 0. Not 0 but null. And if okay, then so we have at least 4 bytes in this case, and if this is okay, then we can use an integer 32 pointer p len data is equal to uint32 pointer pbuff len data is equal to network to host long of p len data. At this point, we have consumed the size of uint this, and we can increase the pointer pbuff plus equals to this thing. So we have consumed the length, and now if and then I think we can just say string is equal to string pbuff and pbuff and no, but pbuff plus, oh no, and we have the plus, come on, plus if plen data, no, if the length of the data is bigger than the length we have left in our buffer. So if somebody is telling me that if somebody is giving me a buffer and tells me, for example, of 60 bytes and tells me there is a string in it with 100 bytes, this can't be true. So we return null in this case as well. But if this is fine, then we can initialize our string with the data of the buffer. And Yes. Then we can... So this is the length left, len buff left. Len buff left. Let's see, the C++ string constructor. I think you can use a char pointer and then the size. So we have initialized our string variable, that's fine, and at this point we can return a valid pointer, but we also have to increase the pointer to the len of the data we have consumed. And then we just return the pbuffer variable. This should be fine. And now we can try to get yes, that's cool, because I want to see if this works. If this is working. Let's see. P string P header. Boah. Mbuff, pbuff, yes, okay. I want to get rid of the P string. Pbuff is equal to mbuff plus P header size. We have consumed the header at this point, and then we say pbuffer is equal to this fetch function pbuff and pbuff and pbuff and is always mbuff, no, yes, plus mbufflen, and then I want this to have a string. String is there, whatever. So then I can get rid of all the if not pbuff and then okay, this was intended. Could not fetch string. And then if str is not equal to this thing, then go out. That's cool, because now I have the already increased buffer pointer, And now I could try to fetch another string. So this should be working. String.c string. I don't need this anymore, and I don't need this anymore, so this is fine. I think this is it. If pbuff I think this is fine, because in the case if I enter a higher value at the start than the end, then this should be able to be negative, and then we return null. Let's see. Invalid conversion from const char to char. Yes. This function cannot know if I want to change the data. This should be a const pointer, but I want to return a pointer to the next. I don't want to return the length, because if I return the length, then yeah, okay, let's yes, this should be fine. Okay, comparison of integer and different signedness. Size of your integer. Yes. Yes, len requested, that's fine. Okay. No. Oh, then. The length of the buffer left. No. I think this is easier. If p buffer is bigger than pbuff and then return null. Unused parameter, okay, that's fine. Okay. Let's see if we have the same behavior as before. SSH, localhost 4001. For telnet you don't need, oh yes. Oh, I think it worked. That's cool, that's cool. So at least we have created a useful function today. Buffer string fetch, because this is used so many times. That's buffer fetch, buffer fetch. Should I use? Yes. I will use an overloading. So if I put another data type in it, it's fetching the data as well. That's okay. That's cool. Yeah, cool. This makes a lot more fun, and as you can see, it's way easier than coding Advent of Code. Advent of Code is very algorithmic. You'll have to use your brain, and this is just coding. What do I want to have? So this is fine. The next thing is, yes, p header is I have to check at this point. I set the header, and then I have to check if this is an authentication request. We didn't check this field. This field must be in the not connection protocol, user authentication protocol. It has the value 32. That's 50 decimal. That's an user out request. Yes. So if this is did not receive a user authentication request, did not receive an authentication request, and at this point received an authentication request, and we have consumed the header. Yes, like this. What am I doing at this point? This does not make sense. Received authentication request. Okay, fine. I increase the buffer. Pointer. P header. Yes. Yes, perfect, perfect. And at this point, I can check which kind of or what kind of method does this not channel data, not channel. This is the non-authentication request. So this is the last thing I want to check. We have a service name. Yes. Okay. We have a string. Service name of the service. And we have a method of the authentication. Authentication request, fine. We have checked the username in yes. And we have a username. Oh, come on. Name user. So let's see. Oh, come on. We fetch from the buffer the username. Could not fetch username. Could not fetch service. Yes. So I don't need str. Could not fetch service string. Nice. At this point, I say could not fetch username. Then user as requesting access for service. Name user.c string. Name service.c string. Name user, fine, and then could not fetch service service name. So I get the username and the service name and the method name. Is requesting access for service. Name method. Yeah, this will be the last code line for today. User requesting access for service using method. Okay. Let's make a warning so we can see the stuff. Ja, okay. User Joe requesting access for service SSH connection using method none. That's cool. Oh, I want multiple single lines. User is requesting access for service using method user requesting access for service using method and I put these things here. Yeah, fine. Yes, this is true. So user Joe requesting access for service access requested user service method access requested user service and method That's cool because now I have all the data in strings and that's way more convenient to handle. And now I can just say if name method is equal to none, then I break and I respond with not okay. Then I should be I got a packet, and because I got the packet, I have to reset the timeout, and I am still in the same state because I want to get another authentication request from the client. And then this must be a different authentication method other than none, and then I should respond with is okay. So in this function I have to send if these are the authentication requests, that's fine. So I have to, so this is a cool function, that's done. Receive, wait, I will make the state machine shorter. Because if I do this, then I have to check the new authentication request instead of the session receive. So I get a different packet now. That's fine. So I just say at first I decline the request if it's a none request, otherwise it's okay, and then I'm in the idle state. And the only thing I still want to do is checking this okay variable, and I have two options to respond. The first one is success. Otherwise I have two responses to authentication requests. If the server rejects the authentication request, it must respond with the following: user out failure. So these are the packet header things. Now I have to add an byte, and this byte is the let's make it this way. If okay, then otherwise I must send a failure. But if so, the user this is the user out success message. If this is okay, then just add this byte. But if we respond with an error, then we have to add let's make a negative if. Yes, that's fine. And at this point fine, but here we have to add more information. We have declined the request, but we have to say why. And if we have a partial success, and this partial success means if we were able to understand the request. So the client knows, okay, the request itself was the structure of the request was okay, but the request itself got denied, so, or rejected. So we add another stuff, and that is blob add message, and we tell, and then we add another byte. And let's see, so Let's see. Partial success. The value of partial success must be true if the authentication request to which this is a response was successful. It must be false if the request was not successfully processed. And I think this just needs to be 1. I think a bool is just a 1, but we can check this, hopefully, in the documentation of RFC whatever. Let's see. Okay, let's see. Architecture, maybe. Is this the architecture? Yes, bool. Oh, boolean. Yes, yes. That's in the SSH protocol architecture. A boolean value is stored as a single byte. The value 0 represents false and the value 1 represents true. All non-zero values must be interpreted as true. However, applications must not store values other than 0 and 1. So as a server, we have the obligation to the requirement to set 1 as true, but we should be able to process another value. So be conservative by what you send, and be open to whatever you get. So yes, this is fine. So now we just need to tell the client what is this? Come on, what the hell? Okay. We have to tell the client what kind of methods are allowed. So a list of allowed methods, and these are public key and password host based. Let's see. I just want to support this is required, but I don't care, so I just tell the client that only password authentication is supported, and that's it, hopefully. Let's check this. Vecbyte. A vector of bytes. I want to make a hex dump. What I have sent. Okay. Message.data. Message.size. That's oh, cool. Now the SSH client. Oh, okay. I have to set a different timeout. That's but it's working already. That's cool. So in milliseconds. M T timeout in milliseconds. Oh, this is so cool. So, password, that's fine. We tell this thing that now we have a different timeout. How fast should we type this thing? Let's say password timeout is 30,000. So here I have to say timeout is no. Not for this service request, but for this thing. That's fine. That's fine. And now here we have a different timeout. It's not a SSH a message timeout, but a password timeout. Yes. So we got access requested, user show, service SSH connection, method none. We rejected the request and told the client that we want to have a password authentication. This is valid for 30 seconds. And now I can type my super secure password. Ha! That we received the timeout already. What? Bad message during authentication. Type 84. But I didn't get any. No. Perfect. Access requested. Oh, that's cool. That's it. We requested, we declined. We declined the first attempt with method none, and then we got a new method. That's fine. That's cool. And now, but there is something strange because yeah, that's of course we have to make a return here. That's strange. Permission. What? No. Password. we want an SSH connection with none, and we reject it. But that's cool. Permission denied, please try again. That's cool. So for some reason okay. This is the default one, and now I have to say true. That does make sense. So let's try again. None. And now the client goes to the next step, because this is the this is the access requested with the method password, and that's a bad example I made. I type in I type in my secure password. Packet to beacon. Okay. But as you can see now, as I can see the password in clear text. Let's see. My pass, and this is now I can check the password. I see the password in clear text, and the password of course must be hashed, and only the hashes, the hash of the password must be stored on the machine, on the server, and these hashes must be compared. And that's it. So this is way easier than advent of code. Okay, I think this is it for today. We have done a lot of cool stuff. I'm quite happy. I wasn't motivated at the beginning because the day was long. So now we rate somebody. Let's see first. No, let's rate somebody. Oh, Gyros is online. Cool. Let's rate Gyros. Bye everybody. And hope to see you again next time. And I hope to see you at Gyros. He's a cool guy. He always does crazy stuff.